Hello, my name is Kaja-On-Site, and today I will present you our paper called On-Site Visualization using BIM and Extended Reality. So our article focused on merging BIM and expanded reality for better visualization on a construction site using our advanced device called Trimble XR10 with HoloLens 2. So today I will talk about on-site visualization, then I will show you our experiment, and then I will talk about the results of our survey. So our goal was to show the advantages and disadvantages of the advanced devices, and to compare advanced approach and traditional approach on construction site. So visualization is visualizing some ideas. The first picture is an easy way of presenting visualization in construction site. It starts with an idea. The investor has an idea and then tells the architect. He writes down the idea as plans, and then we have the main contractor that makes this idea, and he realizes it, and we can monitor it with the advanced devices. So for our article, we used, as I said, the Trimble XR10 with HoloLens advanced device. It consists of two parts. The first part is the Trimble XR10, the protective helmet, and the second part is HoloLens 2 visor. It was made by Trimble and Microsoft. So the main it was made for better visualization at construction site. So for our experiment, we used the facility retirement home in Kozja in Slovenia. It has 3 floors, ground floor, first floor, and second floor. It is reinforced concrete and brick construction. It has a capacity for 47 residents, and the main contractor is Gizgradnja. The construction process is still in process because of some final things. The first part of our experiment was the preparation of the 3D BIM model, because the 3D BIM models are very large files. We just focused on the first floor of our building. The 3D model we got from Gizgradnja, it was made in ArchiCAD, and we transported the smaller version, the first floor, into the program Trimble Connect. On the right pictures, we can see the adapted model. Then we equipped the 3D BIM model with QR codes for better placement the model in the real environment. We can see that we chose some starting points for better adjustment on the real building. The second picture is the QR code. And then we had to place the QR code on the model, on the building, so we could place the whole first floor digital model on our real environment. So we can see the 3D BIM model is positioned on the third picture, and this was the result. Then we wanted to show also the building process in the sequence. We made a sequence of a room in the first floor. The sequence contained 7 steps. The first step was the construction of external reinforced concrete walls. The left picture is the 3D BIM digital model in program Trimble Connect, and the second picture is the digital model placed in the real environment. Then the second step was the internal brick walls. The third step was the plaster. Fourth step was inner plasterboard. That was the first step of the drywall. The fifth step was insulation inside. Sixth step was outer plasterboard. And the seventh step was ceramics. These are some pictures of the actual construction site of our steps. The first picture on the left was the first step when no vertical construction was built. Then we can see the reinforced concrete walls, then the brick walls, and the drywall. This is the sixth step, and we also made a survey. We invited 40 people, 40 workers on the construction site to be in our survey, but 15 of them decided not to participate because they thought that advanced devices in construction are not really working for them because the traditional way is the best way. So we gathered only 25 people to be in our survey. The most of them were men, only 5 were women. It's because that in Slovenia most of the workers are still men. And then the most of them were workers, construction workers. Some were civil engineers, supervisor, foreman, project manager, and other like IT guys and craftsmen. And then we asked them if they have already had experience with such device, and the most participants said that they never have experienced that. It was their first time. And the main questions were about the user experience. We asked them if the use of the advanced device is easy, if it is comfortable to wear, if the display and the sound were satisfactory, if the receiveness of the commands were good, and we asked them if the use of the advanced devices is useful or welcomed. So we can see that most of the participants agreed with all that is said, and they thought that our advanced device had a lot of advantages. So we can see that the advanced device Trimble XR10 with HoloLens 2 had a lot of pros and cons. The pros were good accessibility, very good visualization, easy placement of the digital 3D BIM model, easy coordination and communication, and also safety. Some cons were difficulty to wear the device because it was really heavy. The biggest con for me, for our experiment, was the poorer visibility in bright light. So our experiment had to be done in very early hours or very evening hours. We had some problems with software, with updates, and there were some deviations, up to 10% in the placement of the model. With the results of the survey, we can say that the participants thought that the device is very good to use, it's very good for good visualization on the construction site. They said that they thought that it is really welcomed, but they also said that the traditional approach has a lot of advantages as well. So if we can conclude, if we want to compare the traditional and the advanced approach, the traditional has lower initial costs. It is very good known. The technology is very good known. It has fewer software tools, and it is easier for the implementation on construction site. But if we look for benefits in the advanced approach, we can say that it's really better in visualization and understanding, communication, safety, and it is safer and cheaper in the last final steps. So investing in XR technologies yields significant benefits for improving productivity, communication, project understanding in construction problems. Thank you. Projects.